This video will cover why the exterior angles of a polygon always sum to 360 degrees, no matter how many sides that polygon has. So as we're already aware, and from a different video, we've discussed that the interior angle sum is going to be dependent on the number of sides or angles that polygon has. However, when we look at exterior angle sums, it's always going to total 360 degrees, and this video will answer as to why that is true. So if we extend out our sides to form these exterior angles, let's call this interior angle 1, 2, and 3, and the exterior angles will form 4, 5, and 6 for this particular triangle. Just a reminder of what those exterior angles are. What we're saying is that if we take the measure of angle 4 and add to the measure of angle 5 and add to the measure of angle 6, we expect to get 360 degrees. And that would be true for all of these polygons that I have displayed here. In a previous video covering interior and exterior angle sums and polygons, I did show two examples, the triangle and the quadrilateral, as to why they would sum to 360 degrees, but we're going to generalize to polygons of n sides. So the idea behind it is to observe that when we look at an individual interior and exterior angle pairing, they're going to form a linear pair. And we know the linear pair forming a straight line has a measure of 180 degrees. And we also need to know, how do we find the actual sum of the interior angles? And that is, as we've discussed before, a result of us using our knowledge that the interior angle sum for a triangle is 180 degrees, which we've also proven before, but then taking that fact and realizing that we can always subdivide polygons of sides greater than 3 into triangles. So for instance, if I draw diagonals from a chosen vertex, like I am in this quadrilateral and pentagon, you'll see that that quadrilateral was subdivided into 2 triangles and the pentagon into 3. And from that, we can derive a formula for the interior angle sum being the number of triangles in the polygon that can be created, which is always the number of sides minus 2, times 180 degrees, which is representing, again, the measure of the sums for the interior angles of our triangles. So essentially, we're taking how many triangles can we form with diagonals and multiplying it by 180. So using those two facts, we can figure out as to why it is true that the sum of the exterior angles in a polygon is always 360 degrees. The idea is going to be derived or determined through this equation. So we're going to take the sum of interior and exterior angles together should be equal to the sum of the exterior individually plus the sum of the interior individually. And that should make sense. And what we're going to do is solve this equation for the sum of the exterior, knowing what the sum of the interior is. As we've already discussed, it's going to be 180 times n minus 2. That's a representation for it. And also, we know sum of interior and exterior together. That's going to be determined by, again, looking at when we have a pair of an interior and exterior angle that's a linear pair, and we just say, well, how many linear pairs do we have per polygon? Well, the number of linear pairs is going to be equivalent to the number of sides. So for our triangle, we see that we have 3 linear pairs. For our quadrilateral, you'd have 4, the pentagon 5, and so on. So we can generalize that to say the number of linear pairs totaling 180 times the number of sides, which is going to be represented by n, as it's represented, or that's what it's representing in our sum of interior over here. So n is representing the number of sides. So now, like I said before, all we have to do is solve for the sum of the exterior in this equation. So we have 180n is equal to, I'll just write SOE for sum of exterior, plus I'm going to distribute the 180n minus 360. Now I'm going to move this 180n in the 360 to the other side, and we'll see why the sum of the exterior is always 360, no matter what the value of n is. We'll see that this 180n will cancel, and we'll have 360 is equal to the sum of the exterior. And that is why you can see that the sum of the exterior angles is not dependent on how many sides or angles that shape has, because that is represented by this variable n, and that has canceled out. So it is true, no matter how many sides our polygon has, the sum of the exterior angles will always total 360 degrees.